not adjusting the darkroom anyway, so.
All right, this I think is the most important stuff that we do with the trig. It's the actual equation, so you're solving for stuff. You're going to be finding out what the thetas are. The biggest thing that you're going to have to deal with is deciding what kind of graph that you should be pulling your answers off of. Should you be using the wavy graph, or should you be using the unit circle? And then once you've made your decision, it's actually pretty easy to figure out what the values are going to be. All right, so what kind of numbers am I going to end up? Well, let's just do it this way. Let's start solving this one. So I know that I'm not going to be able to get theta completely by itself, but I'm going to be able to get it pretty much by itself. So let's focus on getting the trig piece by itself right now.
Plus 1.
Add 1 to both sides. Then what?
Divide by 2.
Divide both sides by 2. So I get sine theta equals 1/2. So in other words, I know that my opposite is 1 and my hypotenuse has to be 2. What kind of triangle, first of all, has 1s and 2s in it?
30, 60, 90.
It's got to be a 30, 60, 90. So then we have to make the decision, is it 30s or 60s? I want the opposite to be 1 and the hypotenuse to be 2. Well, the hypotenuse is always 2. Well, is it 30s or 60s where my opposite's going to be 1?
It's going to be 30s.
30s, because that's the short side, right? So we know that I'm going to have this situation where my theta is here, my opposite is 1, my hypotenuse is 2, which is going to force that one to be radical 3. So what angle is that in radians? 30 degrees in degrees, but in radians?
Pi over 3.
Pi over 6. Okay, so that's one of my answers. Why will I end up with more than one?
Just keep on repeating.
You go the other way.
This is giving me more than one answer.
So you have like more value.
Well, sine is positive in more than one quadrant. What other quadrant is sine positive in?
Second.
The second quadrant. All right, because that will also give me an opposite of a positive 1, a hypotenuse of 2. Now my adjacent would be negative, but there is no adjacents in sine, so that's why I end up with 2 quadrants. What angle gets me here? Well, if I went all the way, I'd get 180, so it'd be 150 degrees. What is that in radians?
5, 6.
5 pi over 6. Good. You can do that too. That'll get you there as well. Just make sure you simplify it. The other way to think about that one is this is pi here, right? Which would be 6 pi over 6. And I'm 1 shy of that, so it's 5 pi over 6. That's kind of how I do it in my head when I'm trying to figure them out. Good. So you get 2 answers. So the easy way to remember this, and I don't know if we did this before. Did we have this list up here where which quadrants is positive for which trig function?
Yeah. A,
All
S,
students
T,
take
Big man.
calculus.
Which isn't true. In my school.
All right. So that means that all of my trig functions are going to be positive in the first quadrant. Sine will be positive here. Tangent will be positive here. Cosine will be positive there. They will be negative in all the other ones. All right, so this one's already done for me. Cosine of theta equals 1 over 2. So that means that my adjacent is 1 and my hypotenuse is 2. What kind of triangle makes that happen? 30, 60, 90. Which angle in particular is going to give me an adjacent that's 1? 60. 1, 2, radical 3. So what angle is that in radians? That's degrees, but 60, and then you just have to convert it. So pi over 3. Where else is cosine positive?
Fourth quadrant.
Fourth quadrant. It's going to look the same shape. What angle gets me there? 60 shy of being all the way around, right? So 300, you're right. And then what is that in radians?
times pi over 80. Can you just do pi?
Sure. So if it's 100, what did we say it was? 300 times pi over 180. So that's going to get me 300 pi over 180, which is 30 pi over 18. Take a 6 out of both of those, so I'd get 5 pi over 3. Okay. So you kind of have to decide, for these were both unit circle problems, right? So you have to decide, all right, I'm definitely using the unit circle, and then what angle is it that I'm using within my unit circle to figure it out? All right, what should I do for this one to start getting the trig by itself? Subtract the radical 3. Okay, then what? Divide both sides by 2. So sine comes out to be negative radical 3 over 2. So that's my opposite, and this is my hypotenuse. Now, first of all, what quadrants are we talking about? Because sine is negative now. It's going to be in the third and fourth because it's positive in these two. So it's got to be negative in the other two. So I know that I'm dealing with the third and fourth. And then my opposite is radical 3 and my hypotenuse is 2. So when is that going to happen? What kind of triangle?
30, 60, 90?
Definitely 30, 60, 90. Is it the 30 then or the 60 that's? 60. Because it's got to be the opposite is the radical 3. And we already know that it's in this quadrant. That one's negative. That one's negative. Okay, so we have to figure out what angle gets me to there. 270. And what would get me to this one?
300.
300. So we already had that one. That one was what? 5 pi over 3?
How do you get 270? We're going from the 0 degree?
Yep. So I had to go 180 and then I had to go 60 more. Oh, that's not 270.
240.
240. There you go. Better.
Okay.
Good call. All right. So what is 240 degrees then in radians?
76.
No. Well, it's going to be thirds.
Or
We know that.
Thirds.
Well, this is 3 pi over 3, right? And then I went one more. There you go. Easy enough? Right, you're not always going to be using unit circle, though. Sometimes you'll end up having to use the other ones.
The wavy graph.
Yeah, the wavy graphs. All right, now this one, when you end up with sine of 2 theta, you kind of have to think outside of the box. Don't change the problem that much. Didn't we already do sine of x equals 1/2? We did that over here. Sine of theta equals 1/2. We came up with pi over 6 and 5 pi over 6. All right, so I'll spare you the work again. So we knew that it was pi over 6 and 5 pi over 6. That's when it was sine of just a variable. When there's more than just that variable in there, what we really solved for was this. We want theta, right? So what do I do at this point? So what I'm saying is, if you end up with something other than just an x or a theta in here, solve it like it's just an x or a theta. So you'd still get, you'd have sine of theta, let's make it x, equals 1/2, where this is my opposite and this is my hypotenuse. And then we know that it's positive, so it's got to be in the first and second quadrant. We know that my opposite is 1, so it's got to be the little guy. So I'm going to end up with this and this. So I'm going to get pi over 6 for this one, and this one is 5 pi over 6. Right? But remember, it wasn't x. It was really 2 theta. So this is 2 theta. Follow that?
It's kind of just substitution.
Yeah. Now, keep going. Solve for theta.
So just divide everything by 2.
Yep, divide both sides by 2, which is the same thing as multiplying by 1/2. So I'm going to get pi over 12 and 5 pi over 12. Okay, now I'm not quite done. Because when we graphed these things, what did this do to the graph?
Period change.
It was a period change. So is this one going to be happening more often or less often? Is it going to be a nice curve? Is it going to be one that goes quicker or one that slows way down?
It's gonna be a nice curve.
No, nice curve is what we're used to. That's sine of x. When I put a 2 in there, it happens more often. So I have a lot more answers here. So what you have to do is, these are going to be your starting solutions. They are solutions. That's where you're going to start. And then you got to keep going, and how you figure out what you're going to keep going is you take this, and you do just like we did when we were graphing. Set it equal to what the period is supposed to be for that trait function. What is the period supposed to be for sine? 2 pi. It repeats itself every 2 pi. Solve for theta. Divide both sides by 2. And it comes out to be pi. Keep adding that value onto it until you run out of space. Right? I only want answers in between 0 and 2 pi. So once your values get bigger than 2 pi, you don't have to do it anymore. All right, so if I add pi here, what am I really adding?
90? No, 180?
It is 180. That's exactly what I'm doing. But I don't want to add pi to pi over 12 because they don't have the same denominator. So how can I rewrite pi so that it has the denominator of 12?
Also be 12 pi over 12.
Good. And I'm going to keep doing that until, so that's going to get me 13 pi over 12. Does that still fit in between 0 and 2 pi? Yeah, when do I stop? When my number is
24 pi over 12.
bigger than 25 pi over 12. So this one I'm going to get 17 pi over 12. Does that one fit? Yep. All right, keep adding. This one will get me 25 pi over 12. No, that one's too big. How about this one? Too big. So I get 4 answers for this one. So you're going to end up with more than just your 2 answers when something like that happens. Right? You just have to keep adding on the new period. Right? So the 2 things to remember is, first, solve it like normal, and then do your fix like we did here. Put it back the way it was and solve for regular theta. That's what got me my 2 in the blue box. Then figure out what your new period is and keep adding on the new period until it's out of the zone. All right, let's try another one. Same
You
idea.
don't have to graph it then, or?
No, you don't have to graph it. You're just using the principles behind graphing to help you get all the answers.
Okay.
Because remember, what we're really looking for here is all the x-intercepts. Okay, that's what we're trying to find. Or how many times in this one we're trying to figure out when sine is 1/2. Well, sine does this. When it happens more often, sine is doing this. So at 1/2, how many times is it going to cross there? 1, 2, 3, 4. I'm going to get four times. Same idea on this one. This one looks really complicated, but if I just change it so that it's tangent of x equals 1, that's not so bad. That's when my opposite over my adjacent is 1 over 1. When does that happen? When is my opposite
45.
and my adjacent the same?
45.
45. When is tangent positive? What quadrant?
1 and 2.
First and third. Good. So what angle is this in radians?
5
Pi over 4. What angle is this in radians?
4, 5 pi over 4.
5 pi over 4. And that's what my answer would be if this was just an x. But it's not an x. It's theta minus pi over 2. So how do I solve for theta in each one of those?
Add pi over 2.
Add pi over 2 to both sides. So this would be 2 pi over 4. So 3 pi over 4. That's one of my answers. This one's at a 2 pi over 4, which is 7 pi over 4. That's my other answer. All right, big question. Was there a period change in this one?
Is the smart board going to fall?
I don't know. It's making weird noise. I think it's this thing. Was there a period change in this one? There was a change. What did this do to the graph? It wasn't the period.
Starting point.
It was the phase shift. All right, so you don't, it's not, is it going to happen any more frequently?
No.
No, it's not happening more often. It just got shifted. So I'm still going to end up with two answers. The only time that you have to find the more than the two answers is when you have a coefficient with your theta. Okay? As long as you don't have a coefficient, if you're just adding or subtracting, you're still going to end up with the same number of answers as you had before. Huh? Okay, practice. I don't know if that's right or not. It was right. Okay, so page 492, 7 through 51. We look at the rest of this week. We're going to finish up well, there's only two sections. We're just going to practice with those two sections for the 4 days. Left in chapter 7. And then you guys will take a quiz over those last two sections in chapter 7. And then the exams are next week. Now, I'm not sure when your exams are for your homeschools and whatnot. So work it out with Borsick and Stanton, depending on when they want to give their exams. For me, basically, I'm going to be here from 7:30 till 2:30 for all 3 of those days. Just come in, take it whenever. I don't care. Whatever fits your schedule.
Friday, take 4-6 and come after my POD exam.
Sometime this week, I'll get you like a list of all the different topics that we went over. I guess you can call that a study guide, but it's more like a checklist. My suggestion on studying for my exams is the same as it's always been. Look over that checklist. If you're looking through it and you're like, oh, I already know how to do that, just mark it off. Don't study things that you already know. Study the things you don't remember or the things that you remember that you weren't very good at. That's how you're efficient on your study time. But like if we get distance formula, I know that's going to be on there. But you're like, I know the distance formula. If you know it today, you're going to know it test day. Just cross that off and you don't have to study that one. So treat it like a checklist. All right, but I'll get you guys a checklist in the meantime. So it'll just be stuff that we've done up through chapter 7. So what did we do this year so far? Chapter 1, 2, 3,
4, 5, 6, 7.
4, 6, and 7. We skipped 5. We'll come back. We'll do 5. When we come back from the exam week, we'll do 8, and then we'll go back and get 5. We still have one more chapter of trig left after this. Alrighty.